Welcome back to HANA Basics for Developers. In this session, we're going to look at how to create tables and views using SQL DDL design time artifacts as opposed to core data and services. Now, 2 videos ago, we showed you how we could create tables using the abstracted database agnostic syntax of core data and services, and we talked a little bit about the advantages of that approach. Now, what we didn't talk about is the disadvantages. One of the major disadvantages, obviously, is that it is database agnostic. And while that database agnostic approach is probably good for certain use cases, such as maybe if you're creating an S4 extension in the cloud or on-premise, and you have a small amount of data that you want to carry along with your extension, but it doesn't necessarily need analytics ran on top of it. It doesn't really need the full power of HANA, then that's something that you could use core data and services for. But in the HANA native development scenarios where we're doing data warehousing and we're doing analytics on top of transactional data and really combining OLAP and OLTP, there we probably need the HANA specific features. I mean, just by the fact that we're calling it HANA Native Development means we want to take advantage of the inherent unique capabilities of HANA, which means that we want HANA specific data types and we want HANA specific features. And the new core data and services doesn't have that, and by intention. And you know, this is going to be a bit of a shift, because in the past we used the abstracted core data services, but it was the HANA specific variant, the HDB CDS. And it contained a lot of HANA specific things. It contained HANA specific data types and features such as partitioning and structured privileges and things like that. Now, the problem that we always had with that was we would introduce a new feature to the HANA database, and of course it would be available immediately in SQL, but then it would always take us maybe another SPS level before we could add it to the abstracted layer, the HDB CDS. So we didn't want to anymore sort of have that lag. We didn't want to have to add all the database specific features to the abstracted environment. So we'll kind of say core data and services, that database agnostic environment, you know, it can run on multiple databases. It's good for certain use cases, but really for HANA native development, why not just use SQL? We already have the SQL syntax for creating database artifacts. That's what DDL, Data Definition Language, stands for. That's the subset of the SQL language that allows you to create and alter database artifacts. And everything has to start there anyway. Even CDS has to be able to generate the SQL DDL. And for developers coming from other environments, if you're coming over from, say, an Oracle or a SQL Server or something like that, you're probably already used to using SQL DDL. So why not just use that? And that will give us full access to all the HANA specific features and data types, and there won't be this lag between when new features are implemented and when they're available. And the other thing that we've done, you know, the other reason that people use CDS for a number of years was because it was the main way that we had a design time artifact, which means it could be transported. And it did all kinds of cool things, like I could just define how I wanted the table to look, and I didn't have to write specific scripts to say alter table, add column, or manage the data that's in the table when I make changes. CDS would do all that for you. It would do data migration. You know, it would drop the table, create a shadow copy of the table, and copy all the data over, and then recreate the table when you had massive structural changes, and then re-import the data. That was one of the powerful features of CDS. So what we've done in the for a little while now in the HDI environment with the SAP Web IDE, we've added all these design time artifacts that use the SQL DDL syntax. They still have the transport capabilities. We can transport this content. We don't have to write alteration scripts, and we don't have to alter data migration scripts. all that functionality that used to only be available to CDS, the HDB-DD artifact in the old HANA repository, is available in this environment, in the SQL DDL artifacts, as you'll see. But at the same time, now we're using standard SQL syntax, basically the create table or create view or whatever artifact that you're working on, and that really opens opens things up as we described. Let's recreate these two tables, this purchase order header and purchase order item, and even the view that we had created 2 exercises ago. And let's use SQL DDL now to create the same artifact so that you can compare and contrast the 2 approaches here. So what I want to do is I actually want to create inside of source. I want to create a new folder, and this time I'm going to show you you can also just create folders directly. I'm going to create a new folder called data, and then inside that folder I want to create a new database artifact, and let's say database artifact. And actually, let's go back and look at this list. And I showed it briefly in the previous video, but notice all the things that are in here. We've got constraints, we've got full text index, we've got synonyms, result cache, roles, statistics, synonyms, tables, table data, triggers, basically any database artifact you can think of, we now have a design time representation of. And most of these that you see in this list are using this SQL DDL syntax approach. So it wasn't as though we had to come up with other formats or other abstracted languages to define the whole range of HANA development artifacts. So by switching to really focus on SQL DDL, it also opened up the support for all these design time artifacts that we never had before. I mean, you look at triggers or constraints. In the old HANA repository, we didn't have a design time artifact for those, so you couldn't transport them, you couldn't put them in a delivery unit. So it really meant that most developers couldn't use those kinds of things. But what I want to do is I want to choose HDB table. And most of these are pretty straightforward. They start with HDB, HANA database, and then they pretty much say what it is that you're creating. We want to create a database table. And let's call this one purchase order header. Okay? And once again, I will go get my syntax over here. EX21B. And let's put this back over here. And what we see, unfortunately, the editor isn't all that great yet. It's basically just a plain text editor. We don't even get the syntax highlighting, and there's no code completion. That's the one downside, I would say, is the design time experience. But the syntax that we get is basically the straightforward SQL create table syntax. You can go to the SQL guide on help.sap.com and see the syntax, the full syntax that you can use here. We're creating the table, and we've got a lot more options here. I'm putting comments on my columns. I'm using the HANA specific data types, which I'm not really taking advantage of all that much in this particular example, but I could use geospatial and text data types in here, which I would not be able to do from core data and services. I can use identity columns. So that's what I'm doing here, to basically attach a sequence or a number range. If you're coming from the ABAP world, automatic generation of unique numbers for the keys. I'm attaching that directly to the table here. That's powerful capabilities. I can still use associations. This is pretty neat. The whole concept of associations that we introduced 2 videos ago with core data services, where we put the relationship between objects in the tables themselves instead of in all the consuming views. Well, for that to work in core data services, we had to implement that at the SQL level anyway, and it's accessible in SQL DDL. So that was also one of the original main benefits of the abstracted core data services. but now we've brought it into SQL DDL, so there's no reason we can't take advantage of the benefits of associations and defining the relationships up front instead of in each view, even when we're using the HANA specific SQL DDL. We can set merge criteria, unload priorities, partitioning, all these very HANA specific concepts, controlling when it's going to do the delta merge, when the table will be unloaded from memory when it hasn't been used. All these very specific technical features can be set here as well. And once again, if you want to see the full range of options, you can always just go to the SQL create table documentation and you'll see all of those. Okay? So we've got our header table. Let's repeat this process and let's do it for the item table now. So I'm just going to come here and I'm going to create another database artifact of type table. And notice that's another neat little trick. You can just start typing table and narrow your selection in the drop-down list box there. We're going to call this one purchase order item. And let's go get the syntax here as well. 1C. Nothing specific to point out here really. We still have the capability. We've got our association to go back to the header table. We're defining the keys here. The item doesn't really offer us a whole lot of unique things over what we've already seen in the header, so we won't spend a lot of time on that. But let's create the third file here. Now this is one other major difference. If we went back to our CDS, notice we had one CDS file that contained multiple items, a header entity, an item entity, and an item view. But with the SQL DDL, you have one file per artifact. So I have a separate file for the header table, we have a separate file for the item table, and we're going to create a third file here now for the view. And I'll say database artifact. Now this time it's going to be a different file extension because now it's going to be the HDB view. Alright, so I can't get that one to choose for me, so I'll come here. Oh, because it's SQL view. If I type SQL view, it would have found it's auto-completing on the description there. And we want to name this purchase order item view. And we will come get the syntax again. D. All right. And this is basically the same view. Once again, I'm not having to supply really a join condition. Notice there's no join on because I'm utilizing the association here as well. I'm selecting from just the item table, but once again, I can reference the items from the header by saying header dot partner. I'm using the association to navigate here, so even in the SQL DDL view definition, I'm still taking advantage of the power of associations. But here, this is really important, with structured privilege check. So this is a particular type of HANA security that provides an extra layer of security for views, very similar to an analytic privilege that we would place on a calculation view. It's going to allow us to do security not just at the view level, to say I can read this view or not read this view, but it's going to allow us to do row level security and use a criteria. We're going to use currency a little bit later, and we're going to give access to certain users to only read data for certain currencies, to only read US dollars or euros. This is a very HANA specific feature. This isn't something that's built in at the SQL standard, but a powerful feature that's often needed in business applications. Core data and services, the .cds file does not have this syntax, but by dropping down to HANA Native and SQL DDL, we're able to take advantage of this HANA specific feature. All right, now what do we want to do? Just like we did with the, just like we had done with the with the previous example, we want to load some data here. So we want to, oh, and actually I was supposed to have put these in a subfolder, wasn't I? Yeah, I wanted to group all these together into a folder called purchase order. Now the folder structure is not important. I'm not using namespaces, so the folder structure does not become part of the object name. But just because I know that we're going to be adding more database artifacts later, I'm going to use the folder structure as a pure design time concept to keep things organized. That's the only thing that it provides. But I am going to go ahead here and create a purchase order folder. And this would be nice. I'll show you how I can select multiple items, and I can use the edit cut, and then I'll just paste those into there. Well, that's nice that it tells me that the paste failed. I'm not exactly sure why the paste failed. Let's try that one more time. And now it was okay, maybe because I had the editors open. Now it's gone through. So now that I've corrected that little step that I missed, once again, like I said, not technically important, just to match up to my exercises, and because I know later I'm going to be adding more database artifacts, and it just is going to keep my folder structure from getting too messy. But I'm going to add a subfolder here called loads, and this is where we're going to put our just like we had done for our CDS, we're going to put HTTP table data object inside here. So we're going to be, get this one, purchase demo is what we're going to call it. And we're going to put a table data here. Let's go grab the syntax. And the syntax is the same. I'll stop here in a second and show it to you. Just like in the previous video, we just give it the target table and we use the CSV file. So, this works against any table. This is not CDS specific. This is not SQL DDL specific. We're actually just giving the name of the runtime object here. It doesn't matter what design time approach that we use to create the object. So that's the other reason I'm doing this. Well, we want some test data for both our sets of tables, so we can use them both, but also show you this approach to load data can be used for either here. And now let's create our CSV files. It's basically going to be the same thing that we had in the other exercise. So we're going to put header, and we're going to call this 24. Let's get our 2 header records. Same data that we used in the previous video, but now we'll add another CSV file, and we'll call this one item. Get that data. Save those. All right, so I've got all this new content. Let's go ahead and just do a build of the whole database module. It will add our new tables, 2 new tables, and our view, and load them with the initial data. And there we see it's done. So now when we come back over here, we have the CDS created 2 tables, but now we have our 2 tables here. We also, the other nice thing about the SQL DDL is we have a little bit more control over the naming. We can use camel case. We can basically give it whatever name we want. Whereas the CDS, the abstracted, is going to take the namespace and the context and create the name out of it for us. But we can see that our data is loaded. Let's go ahead and look at the item table as well. And its data is loaded. Now, what's interesting though, let's come here and look at the view. Remember, our view from CDS, it didn't have any special security on it. So of course we can see the data If I come here to the new view that we just created with SQL DDL, remember it has the structured privilege check on it. We can see that here, structured privilege check. So when I try to do open data, I am not authorized, insufficient privilege. So even the technical user that owns the container does not have privileges to read a view that has this additional security on it. So we're going to have to add some new roles and some new security to our container before even the container can use the security. But once we do, then we're going to have this very powerful capability to do row level security. And that's what we're going to see in the very next video.